Hello, and welcome back to the ADILOS project. This is Brian again. I have an update regarding a new feature. We have two additional subsystems to demonstrate how ADILOS can now be used for web login. In a previous video, I described how a smart device running Keymaster could authenticate, that is, log in to a gatekeeper. We explained how the user selects a key, scans a challenge, and displays a response as a QR code. The gatekeeper gets that response by scanning the code. The result is the gatekeeper has cryptographic proof of the keymaster's public key and can then check that against an authorized keys list. In the physical scenario, the keymaster and gatekeeper have to be close together for the scanning to work. We mentioned that ADILOS could be used to enable access to remote computers and websites, but at that time the protocol did not support it. To illustrate the network case, let's begin with the keymaster, the same one as before. We add two more subsystems called KG Agent and KG Server. The software is published on GitHub as shown at the bottom. The Keymaster runs on the user's personal smart device. Keymaster is the holder of the user's private keys and therefore custodian of the user's identity. The server is a program running on a physical or virtual device somewhere on a computer network such as the internet. Our initial implementation acts something like a web server, but uses a slightly different protocol. As the Keymaster does not use the network, we added a new subsystem called KG Agent. This is a program that communicates both with the server over the network and with the keymaster over the optical channel. Although the figure displays the agent as a separate device, an agent could be another process. Multiple implementations are possible. An agent could even be another app on the same device as the keymaster that does have network access permission. The ADILOS protocol now supports a message exchange that enables these three parties to establish a shared logical session in which every participant knows the public key of every other participant. The session is valid only as long as the network connection exists. Let's take a closer look now at the new protocol with a message interaction diagram. Time proceeds from top to bottom. Whenever a new connection is created, the server generates a new public key just for that connection. The server also makes an elliptic curve digital signature of that key and includes both the key and signature in a challenge message. Let's call that key and signature combination one message part. The agent receives the KG server's challenge, adds its own session unique public key, and signs the server's signature. These two parts are bundled and sent to the keymaster as two parts. Keymaster receives the two-part message from the agent. Note that our keymaster still supports the gatekeeper challenge that contains only one part. The number and signature composition of the parts is the way that the keymaster can determine whether there is an agent involved in the session. Keymaster is then used to sign the agent's signature and return a response to the agent. Agent adds the keymaster part to the two parts sent to it to make a three-part message returned to the server. Now the server has a cryptographic chain of signatures and can verify there's an agent and that the keymaster has signed the agent's signature and therefore approved its involvement. The server also has the public keys of both the keymaster and agent. Both are needed because the server needs to know the end user's public key to determine access. The agent's public key is needed because the agent and server have to sign every message they exchange over the network. Now let's take a look at the roadmap for ADILOS. We invite anyone, especially those with expertise in cryptography, to check out our basic approach and confirm that we haven't done anything wrong with the mathematics. And even if our approach is sound, it is possible the ADILOS software has bugs. So we also invite anybody to test and contribute to the code. The initial Android version could use additional features such as backup and user interface improvements, like copying the response to the clipboard. A significant number of users have Apple, so we hope for an iOS port. It would also be an exciting project to see if we could add ADILOS support to devices like Trezor or Ledger Nano. We welcome any organization in the access control business or with any such needs to consider supporting the ADILOS protocol. We would like to help promote ADILOS as an open source and open standard. Soon we would like to encrypt the connection between agent and server using elliptic curve integrated encryption scheme. In the next video we will demonstrate the software in operation in the lab. Thanks for watching.